6.3 is areas under any normal curve. So first off, we look at our normal distributions. This is what we did back in 6.2. What you're going to basically be doing now is changing an x value to a z value, looking it up in your table, and then you're going to find the probability that goes with it, or the area under the curve that goes with it. So we're taking what we did back in 6.2 and kind of expanding on it. So now your first step each time is to find your z value. So if we look at example 6, it says we have a normal distribution, mean is 10, standard deviation is 2. We're going to find the probability that an x value selected at random from this distribution is between 11 and 14, or the probability that 11 is less than or equal to x is less than or equal to 14. So you need to find the z values that go with these two numbers. So remember, x minus mu over sigma. So we're taking 11 minus 10 over 2. We should get 0.50 then. And then 14 minus 10 over 2 will give us 2. Remember, your z values in your table are 2 decimal places. So now what you want to go to is your table. You want to look for when z is 0.50 and when z is 2.00. So I go over to my table then. So we need to find z of 0.50. So I've got 0.50, so there we go, 0.6915. And then we need a z of 2.00, so that's right here, 0.9772. So your probabilities or your areas are your two numbers out of the 4 decimal places from your table. Now we've got 2 of them, so we've got to subtract. So 0.2857. I want you to try number 6 here. It's the exact same thing we were just doing, so when you go through it, you know you're going to have to put a probability with an x and a number, and then you're going to change it to z, and then find the probability that goes with it. So pause the video and try number 6. Okay, so for number 6 we have the lifespan of a rechargeable battery is the time before the battery must be replaced because it no longer holds a charge. One tablet computer model has a battery with a lifespan that is normally distributed with a mean of 2.3 years and a standard deviation of 0.4 years. What is the probability that the battery will have to be replaced during the guarantee period of 2 years? So if it's during that guarantee period, we are saying the probability as x is less than 2 because it's within those 2 years. So change it to your z. Change that, you get a negative 0.75. And again, we're going to go to our table and look for negative 0.75. So we have negative 0.7, it's down there. And then we have our 5, so negative 0.75 looks like it's about here at about 0.2266. So that means then my z value at negative 0.75 has that probability or that area of 0.2266. It's less than, so we don't have to change it. So that is our answer. you can go through your calculator with these. So here it says use the normal CDF. I never use this because I think it takes more work to go through than it actually is helpful with. So if you want to go ahead and use it, this is fine. Just make sure you know how to use it when going through your tests and your quizzes. Now, for me, if you don't show me any work, I can't give you partial credit. So at least tell me what you're typing into your calculator, or again, you're not going to get any partial credit. Whereas if you show me how you get your Z and the probability that goes with your Z, I give you partial credit along the way in case you get a number wrong. So again, make sure you're showing what you're doing. Okay, so what we're going to do is second, we're going to hit bars. You want the normal CDF. Now, you always have to have a lower number. If we go back to the problem that we just did together, there is no lower number. So if you look here, it says, if x is less than or equal to a number, choose a lower bound at 4 standard deviations below the mean. So take the mean minus 4 times your sigma. So if I go back up here, we have to take then 2.3 is our mean minus 4 times our sigma of 0.4. So if we do that, that will give us what our lower bound should be. Again, we're going to take 2.3 minus 4 times our 0.4. That gives me a 0.7. So that means my lower bound should be a 0.7 for this problem. Your upper bound then, following the formula, is the highest number it can be, which is 2 for us. Our mean was 2.3. And our sigma was 0.4. I paste it in. So again, it's 0.2266 when you round to your 4 decimal places. So you can use this if you want. You do not have to, because again, you'll be given the tables when you go through for every test, every quiz, and the final exam, you'll have that in front of you. The other part of this section is when we work backwards. So here what you're going to get is a percent. Then you're going to have to turn it into a probability. Then you're going to look for the probability inside the table. You're going to find the Z that goes with that probability. Then you're going to find the X. So we're working backwards from what we just did. So for example 7, Magic Video Games Inc. sells an expensive video game package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the computer fails during the guarantee period. The research department has done tests that show that the mean life for the computer is 30 months, with standard deviation of 4 months. The computer life is normally distributed. How long can the guarantee period be if management does not want to refund the purchase price on more than 7% of the Magic video game packages? Okay, so here we've got our picture. We have our mu here, it's always in the middle. Now they are telling us we have less than 7% because they don't want to have to do any more refunds than 7% or less. Even though it says they don't want to refund purchase price on more than 7%, they're saying 7% and below is what they want to refund on. So I need to figure out what is that X value that goes with this 7%. That's what we're trying to find. So in order to do this, we first have to figure out the Z value that goes with 7%. So 7% as a decimal tells us our area is 0.07. You got to move your decimal place to the left 2 spots. So now when I want to find my Z, again, we got to look inside of our table.
and you want to find 0.07 inside of the table. So if I look inside of my table here for 0.07, right now I'm over here at 0.05 something, so I got to go bigger. If I go to the next row, I have 0.07s, and now I've got two numbers here, 0.0708, 0.0694. You want the number out of these two that is closest to 0.07. This one's 8 away, this one's 6 away. So that means my z value is negative 1.4, and then when I'm there in this column is 8. So my z value would be a negative 1.48. So again, my z value is negative 1.48. So now when I go through to find the x value, remember we have an x formula that we talked about in 6.2. So we have the z times sigma plus our mu. Our sigma was 4, our mu was 3. So if we plug everything in, we get about 24.08 months. So we need to make the guarantee period to be about 24 months to have less than 7% returns. Now if you want to find your A value, you've got these three pictures here that will help you. If you're shading to the left, you're going to just do what we just did. If you're shading to the right, the first step would be to take 1 minus whatever the decimal is, then find it in your table. If it's between, you're going to take 1 minus your decimal divided by 2, you're going to find that value inside of your table, which is what we're going to be looking here at example 8. We have 90%, so that means we got 0.09, sorry, not 0.09, I'm thinking about my 0.07, 0.9, because you have 90%, so you move your decimal over 2 places to the left, so 0.9 goes with 90%. You're going to find your z value, because right now we have a picture here that says, here's my negative z, here's my positive z. I want everything in between these, so it's 0.9. So because we're shading between two values, we take 1 minus our 0.9 over 2, and we then get 0.05. So now what we're doing is looking for 0.05 in the table. And we are still close to it here. So again, 0.05. So if I look for 0.05, I've got some 0.05s here. Now between these two, I've got 0.0505, 0.0495. Both of those are the exact same distance from our 0.05. So it does not matter which one you choose. Your numbers will be slightly different than when you go back through and find what your x values are with it. But if I want to go under and not over, I have negative 1.6 and then 5, because my 0.0495 would be, I guess, under the 0.05, but again, both of them would be either one okay. So I would accept a negative 1.65 or negative 1.64, either one. Now that's the negative z. If we want the positive z, we then do positive 1.65, because we want to move it in between the negative and the positive of the value. Now I want you to try this one. Again, see what you can do. We'll come back together and we'll go through it again together. But see see if you can figure out what you need to do off of those pictures from the last page. Okay, so hopefully you were able to try this one, see what you got. It's okay if we make mistakes. We can go through, we have erasers. Going through these, it's good to practice on your own just so you see how it applies to what we've done so far. Now we're looking at 3% to the right of Z. So that's important. Again, there's my middle there. They want 3% to the right of Z. So they're saying Z's over here. This right here then is 3%. But remember, if we're in our table, we need everything left of it. So I don't want 3%. I've turned into a decimal first. So that would be a 0.03. If I want left of that, we have to take 1 minus 0.03. So that means then we would be looking for 0.97 inside of our table. So if you look for 0.97 inside of your table, we want to go to the positive side. Okay, so 0.97. I've got a 0.9699 and a 0.9706. So I would go with this number then because it's only one away from 0.97. So that would be a 1.88. Now we're going to use that then to solve for part B. So remember, x equals our z. So we know what our z is. In this problem, they're telling us we've got a mu of 40 minutes. We've got a standard deviation of 5. They want to know after how many minutes can we expect all but 3% of the test to be completed. So if it's all but 3% of the test, we're saying 97% of the tests are done. So if we plug all this in, we've got 49.4 minutes. So we are saying after about 49 minutes, roughly 97% of the students should be done with their tests. Now, you can also go through part B here with your calculator. The problem is, though, you have to only be able to use this if you're given the area under your curve to the left. So, if you would put, for this problem, 3% in, you're going to get it wrong because 3% is not to the left. So the left would be then the 97%. So when you go through this, you need to make sure that you take the number that is to the left. And you're not doing percents, you're going to do decimals when you go through it. So we go second, and we're going to go to our bars, and now we want our norm. Okay, so for our area, if this one was 0.97, again, you want to the left. My mu was 40. My sigma was 5. Now, newer calculators actually let you choose left, center, right. Older calculators do not. So we see 49.4 then for our answer. So if you want to use the calculator, you need to learn how to use it then, and you need to make sure you show me everything that you're typing into your calculator. I will not be using it. I will be going through and showing all my steps and all my work. Many of you, it's probably going to be much better if you just stick to the formulas, because it's the exact same 2 formulas every time. You're going to keep looking at your table each time too. Now when we get to chapter 7, chapter 8, those will use the calculator a lot more because it'll be so much easier to do that. But right now, I highly suggest that you just use the formulas and not the calculator for chapter 6.